In the earlier videos on the subject of gravity, the last thing I remember saying was that the orbit of the moon started as a very eccentric ellipse and gradually turned into what is close to a circular orbit. I now want to show why this happened by introducing the time dimension, which has not played a very significant part so far in our discussion, but it really is critical because it does lead to this change in orbit shape. Let me show you this first diagram, which shows you the elliptical orbit as being of greater radius, twice the radius of the final circular orbit, and the period was much shorter, about 5 days, giving you a higher frequency than the circular orbit, which had a period of about 27.3 days. Now, you can see that when you place this against the time dimension of the Earth, which we're considering as not moving, then there's a much smaller time dilation or time difference between the Earth's passage through time and the moon's passage through time, and this causes an increase in measured mass, and is something that leads to a tendency to reduce the time dilation because of the energy being spent, so to speak, in trying to keep up with time. So let me show you how you use this in the Lorentz transformation equation, which gives you the increase in mass. The velocity of the moon is shown in this equation and is calculated from the frequency. The effective velocity is equal to twice 2 pi times the frequency times the radius. You can see from the diagram that the velocity, which in a circular orbit is constant, but it's shown on this diagram where we just have 2 dimensions, one of space and one of time, that we see the orbital velocity, at least we see a projection of it, and we can extend this to show you the velocity, and the calculation is very simple. The 2 pi is necessary, as with the adjustment to Planck's constant. The 2 pi is necessary because frequency in nature is measured by radians rather than by cycles. So the 2 pi f gives you the frequency in radians per second, and then you multiply that by the radius of the orbit, and you get the velocity. Now, in the case of a circular orbit, that's fairly obvious, but in the case of an elliptical orbit, it's still the same equation, but in this case you have to consider the orbit around the energy shell that we spoke about, this is much higher velocity than the velocity around the circular orbit. As you may remember, the velocity of the moon and the energy shell initially with the elliptical orbit was 24,900 miles an hour, whereas it was much slower, some 2,000 to 3,000, I forget the exact number, for the circular orbit. And with the radius being twice as much, there's about a 10-to-1 ratio in the time dilation. We need to put this into the equation, the Lorentz transformation equation, which I'm having a little difficulty in getting here because of the camera angle. The mass increases by that ratio, and as you see, although v is very much smaller than c, a few thousand miles an hour compared with the speed of light, yet is important enough that over a period of 4.5 billion years, it makes a difference. And that's the reason why the orbit eventually became more circular, and this is a tendency with all moons and all planets. That's the end of this video. I'm going to talk later about other interesting things about the theory of gravity. Thank you.